How far away is the North Star? This is actually a great question that is most easily answered with scientific notation. So I had to look it up, and it is this number of miles away, which is a huge, huge number. What makes it a little bit easier to understand is this 2.5 quadrillion miles away. What makes it maybe the easiest to understand is the scientific notation form. It is 2.5 times 10 to the 15th miles away. To get from that really, really long first number that we saw to scientific notation, all I've got to do is to put my decimal, so I've got just one number in front, and then I count the number of places that I have after that first number. And it turns out that I've got 15 places after the number 2. So we write that as 2.5 times 10 to the 15th. The scientific notation is written in a very specific way as a times 10 to the n, where a, that coefficient, also called the mantissa, is a number between 1 and 10. And then that exponent n is an integer. So that means that that exponent cannot be a fraction. It cannot have decimals in it. So first, let's go through some examples of things that are in scientific notation and things that are not in scientific notation. So we know it's got to be one number in front of the decimal. So if I did something like 2.5 times 10 to the 15th, like we just saw, this one is in scientific notation. Okay, but what about this one? Let's say that we had 15.3 times 10 to the negative 4. This one's got an integer for the power, which is good. Negative 4 is an integer, but that 15.3 out in front is not a number between 1 and 10. It's got to be a single digit in front of that decimal point. So this one is not. Okay, so here's another example. How about 1.07 times 10 to the 23rd? Is this one in scientific notation or not? If you said it is, you've got it. I've got that single digit in front of the decimal place, and that power is an integer, no fractions or decimals there. So this one gets a check mark as well. Okay, how about this one? So this one's going to be 7.35 times 10 to the 5.8. Is this one in scientific notation? Okay, the coefficient is good, right? The coefficient has that single digit in front of the decimal place, but take a look at that power. That power has a decimal, which means that this one is not in scientific notation. Next, let's work on converting between scientific notation and the decimal form, the regular form that we're used to. So I've got two really similar examples here. That first one is 3.25 times 10 to the 5th. 10 to the 5th, whenever you've got a positive exponent, it means that you've got a very, very large number. Whenever you've got a negative exponent, it means you've got a very, very small number, a number less than 1. Let's start with this very, very large number. I'm going to start by writing out that 3.25. And then I'm going to take this decimal place here, and that 5 tells me I've got to move 5 places to the right, or 5 places to make it bigger. As I'm making it bigger, I'm going to go 1, 2, 3, 4, 5. My new decimal lives right there, and I'm going to fill those in with zeros. So I need a 0, a 0, and a 0. So expressing this one as a decimal or as a regular number, I would express it as 3, 2, 5. I don't want that first decimal anymore, followed by 3 zeros. 1, 2, 3. Let's put our comma in, and let's make sure that we did it right. As I count those places back to where my decimal was, I've got 1, 2, 3, 4, 5 places before that decimal, so I've got the right form. Here comes the next one. That next example is so similar, 3.25 times 10 to the negative 5th. But in this example, I've got a negative 5. So as I'm moving my decimal 5 places, I've got to move it so that this becomes a smaller number. So we're going to move that decimal 5 places to the left. So let's put that 325 over here. So I've got some room on the left. My decimal place in scientific notation was right here, but I've got to move it 5 places to the left. Okay, here we go. 1, 2, 3, 4, 5. This is where my new decimal lives. Let's go ahead and fill those in. I'm a little bit crooked. Let's go ahead and fill these in with the zeros. So I've got 1, 2, 3, 4 zeros here. So as a decimal, I'll put a 0 out in front. I get 0, 0, 0, 0, 3, 2, 5. And you can always go back and check yourself. You can put that decimal back where it was and then count to make sure you've got 5 places in between. 1, 2, 3, 4, 5. So if we're making the number bigger for a positive exponent, we're going to move that decimal to the right, but just remember you're going to move it so it makes it larger. If I've got a negative exponent in scientific notation, I'm going to move it to make my number smaller, which means that we're moving that to the left. Now we want to convert the other way. So this one is 65,300,000. This is a large number. So the very first thing that I notice is that I'm going to end up with a positive exponent on my 10. The example that we're going to do next is a very, very small number. So we're going to end up with a negative number on the exponent. Okay, so this first one, let's put the decimal in so that we get the correct coefficient. I need 1 digit and then the decimal place. So my new decimal place is going to live right here. So as I'm putting my answer together, it's going to be a 6.53 times 10 to the. Now I've got to count the number of decimal places to get me to the decimal that lives in my original number. So that's going to give me, I want the decimal there. So it's going to give me 1, 2, 3, 4, 5, 6, 7. I hope I counted that right. 6.53 times 10 to the 7th, and I absolutely did count that one right. Okay, our next example. Our next example is a really, really small number, and this really, really small number has that 0 out in front. Then I've got 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, 7, 8, 2. I know that this is going to be a negative power on the 10 because it's a small number. My decimal, I want it to live right here between the 7 and the 8. So I've got 1 digit in front of the decimal in scientific notation, times 10 to the. Now I'm going to do my power. So to figure out what my power is, I need to move from my original decimal place, which is here, to the decimal place that I want. So I've got to move 1, 2, 3, 4, 5. This is a small number, so we're going to make that a negative 5. You are doing fantastic with scientific notation. We're going to look at operations with scientific notation next.